Okay, now we are going to discuss question 20. So you are given that the lens formula and mirror formula, which is equal to 1 over f equal to 1 over u plus 1 over v. And f is your focal length, u is your object distance, and v is your image distance here. So if we refer to here, this is positive value, not negative value. Okay, next. So the first question is state the type of lens and the type of mirror for the value of f to be positive. So in order to have positive f means that it's a real focal point. So it's a real focal point. So in order to make a real focal point, so we have a concave mirror where the light rays is parallel to the principal axis. They will pass through the focal point here. They will focus on a point. So this focal point is a real focal point because all the light rays pass through it. So this one is positive f. Well, for converging lens, same, parallel light pass through parallel to the principal axis. The light pass through will focus on that point here, which is a focal point, and this point is a real focal point because all the light rays pass through this point. So this is known as f positive. So the answer is concave mirror and converging lens. So number 2, if the object is placed in front of a concave mirror and the image of the object is formed in front of the concave mirror, state the type of image formed. So both image and object are at the same side. So we have object here. In order to determine the image of the concave mirror, there are few rays you need to draw. So you have to draw at least 2 light rays. So here I will show you 2 light rays. The first light rays will be parallel to the principal axis and pass through the focal point. The second light rays will be pass through the focal point and parallel to the principal axis. So here is the intersection point between the 2 reflected rays. So image will form at here. So this is your image. So both object and image are at the same side. So this image is a real image because the light rays pass through the image. So the answer for this, the type of image formed is a real image. Okay. So for the third questions, if a converging lens and a concave mirror form real images respectively. So both converging lens and concave mirror form real image. So in order to form real image, so you need to draw at least 2 light rays for both. It's either lens or mirror. So you want to state the similarity and the difference. So draw out your ray diagram first if you cannot form the image on your brain. So you draw out. So for concave mirror, we have a light ray passes perpendicular to parallel to the principal axis and pass through the focal point. Then the second light rays can be drawn by pass through the focal point and parallel to the principal axis. So the intersection point is your image form. So both of these are at the same side and the image is a real image. Well, for converging lens, in order to form the image, real image, so we have an object here. So a light ray which is parallel to the principal axis and pass through the focal point. Well, the second light rays will pass through the center of your lens. So we have intersection point at here. So this one is your real image because light rays pass through the image. The refracted rays pass through the image. So both of these will form real image. Now we look at the similarity first. For similarity, for both images, we notice that they are both inverted. So this is your similarity. Well, for the differences, for concave mirror, both are at the same side. Object and image are in the same side, but for converging lens, object and image are different side, which is opposite to each other. So we have the answer: concave mirror, image and object are at the same side, while for converging lens, image and object are opposite to each other. So you cannot write your answer as for concave mirror, object and image are in front of the concave mirror? No, because you have to mention that both located at the same side. Oh, okay. Now, B. The diagram below shows an arrangement of a converging lens and a concave mirror. So here, why I highlight here, because in your exam paper it wrote concave lens. So basically, because all the questions, throughout these questions, it already repeated so many times that it mentioned it's a concave mirror, so we take concave mirror as the questions, not concave lens. So now we have two converging lens and concave mirror. So from the questions, we know that the converging lens and concave mirror have the focal point, the focal length which is equal to 10 cm. So for both converging lens and concave mirror, they have positive f. Positive f. So write down at here first. So for this one, f1 is a positive 10 cm. And this one, f2, is also positive 10.0 cm, because converging lens is also 10 cm, concave mirror is also 10 cm. So now, if a bulb is placed at a distance 50 cm from the converging lens, calculate the position from the converging lens. So it already mentioned that your answer must be wrote down as from your converging lens. So the first question is the sub-image formed by the converging lens. So for converging lens is undergo refraction. So this one is the first refraction, where your f is positive 10.0 cm, while your u, look carefully, u must be placed from the converging lens to the object. So this is your distance, which is u equal to 15.0. So it's a positive real image, so it's a positive value. Then you get your v. So how to get your v? Using lens formula plus 1 over v. So you have 1 over 10.0 equal to 1 over 15.0 plus 1 over v. Your v will be equal to 30.0 cm. So then you have to mention the locations of your image. So the image is 30 cm to the right side of the converging lens. Okay, here. Why is right side? Because you know that is a real image form. So it means that the image is formed at here. So 30 cm is here. So this one is your first image. Okay, this is your first image. First image is formed here. Then the second question is the final image formed by the converging lens and the concave mirror. Means you have to find after the first image formed at here. So now this image will act as the object of your concave mirror. Okay, so this will undergo reflections. Why? Because of a mirror. So you have your f is equal to positive 10.0 cm, while your u object, how to determine? So from here, the first image to here is 30 cm. And the object distance for mirror. So the object distance for the mirror, look carefully. So it must be placed, the distance is between here. So this is your U2. So how to determine your U2? So your U2 is 30 cm minus 20 cm. But it's a real or virtual. So look at this one. This one is located to the right side of your concave mirror. So it's actually virtual object. So virtual object is negative value. So you have u equal to negative 10.0 centimeter. So your object distance is a negative value due to the virtual object. Okay, although it's a real image for the first refraction, but it's a virtual image for second reflections. It's a virtual object for second reflections. So you have your mirror equations, which is equal to 1 over f equal to 1 over u plus 1 over v. So your f will be 10 centimeter. Well, your u is negative 10 centimeter plus 1 over v. So you will get your v as 5 centimeter. So this 5 centimeter is actually located at here. Wait, can use paper. 5 centimeter is located at here. Okay, it's somewhere at here. 5 centimeter. Because it's a sorry, it's not here. I'm wrong. It's a real image. So it's a real image. Okay, so the final image is from at here, 5 centimeter from the concave mirror. So concave mirror real image is at here. So it's at here, somewhere at here, your image is at here. This one is 5 centimeter. Okay, so you have to make a conclusion from converging lens because the questions you want to determine from converging lens. So it's actually the final image. You have to write down this answer is located 25.0 centimeter. Not 25, is 15, sorry. Why is 15? Because 20 minus 5. Okay, 20 minus 5, so it's a 15 centimeter. So 15 centimeter. Know that? The final image from the converging lens is 15 centimeter at here. So it's located 15 centimeter to the right side of the converging lens. Okay, so is it clear for this question? So we have this one as this, you have 2 marks, and this one, this questions you have 4 marks. The first mark is for your object distance, and the second mark is for the substitutions, and the third mark is you mentioned that is 15 centimeter from the converging lens. So it's total 3 marks for this one. It's not 4 marks, sorry. It's 3 marks for this one. Okay, next, the last part of this questions. The diagram below shows an object O placed at a distance 20 cm from the surface P of a glass sphere of radius 5 cm and refractive index 1.63. And your n is equal to 1.63 here. So this one is about refractions. You have first refractions on this surface, the first surface here. Okay, you will have a first refraction at here, and then second refraction at here. Okay, the first refraction is on the convex surface, while the second refraction is on the concave surface. So in other words, you can write down your R first in order for you to remember. So the R1 is equal to, because it's a convex surface, it's a positive 5 cm. Well, for R2, because it's a concave surface, so it's a negative 5.0 centimeter. Okay, good. So now determine the positions of the image formed by the surface of P of the glass sphere. So you want to determine the first refractions, the image of the first refraction. So using the refractions equations, so you have your n1 over u plus n2 over v equal to n2 minus n1 over r. So this one is r1 because of the surface P. So n1 is the refractive index of your surroundings. So you have 1.0 because it doesn't mention as any medium, so we assume that is air. So 1.0 for n1. And then what is your image distance? So your image distance is from the surface P to the object, which is 20 centimeter. So your u is 20 centimeter. So 20 centimeter. Sorry, it's 20.0 centimeter. Okay, then n2 is 1.63, the refractive index of the glass sphere, and then v is what you want to get. And then n2 is 1.63 minus 1.0 divided by r is positive 5.0. So you will get the answer b as 21.4 centimeter. So use centimeter because all the value that I substitute for line is in centimeter. So this one is 21.4 centimeter from surface P. So it's located, the image is 21.4 centimeter to the right side of surface P. Okay, so now 21.4 is actually at here. Okay, your first image is at here. Okay, so calculate your first image is at here. Look at it here. So it's to the right side of your second reflection. Okay, sorry. Is to the right side of the second refraction. So in order to determine the positions of the final image, so you have to determine the object distance first. So first you have your f, sorry, not your f, is r, value of r2, which is equal to negative 5.0 centimeter because it's a concave surface, and your u now. Okay, your u2 will be from here to this distance. Okay, so 21.4 centimeter is the image distance of your first image. This one is 21.4 centimeter. So how do you calculate the object distance for this one? So to calculate, you use 21.4 minus 10 centimeter, the diameter of your glass sphere, and this one is a virtual image. Why is virtual image? Because it's located at the right side of your refracting surface, or is in the opposite side to your incident rate, so which is equal to negative 11.4 centimeter. So this one is your virtual object. Okay, so this one is your virtual object, remember? Okay, so now you have your n1. So for n1, for this substitution, we use this equation. So your n1 for now is not 1.0, it's 1.63. Why? Because it's reflected from the glass field to the surrounding. So n1 now is 1.63. Well, n2 now is 1.0. It's different from your first refractions because for your first refractions, it's refracted from air to the glass field. So your n1 will be 1.0 and your n2 will be 1.63. But now, because the light rays is reflected from the glass field to the surroundings, so we have n1 as 1.63, n2 as 1.0. So substitute inside, and your U is negative 11.4. Plus 1.0 over V equal to 1.0 minus 1.63 over R is negative 5.0. So you will get your answer V is equal to 3.72 centimeter. Means the final object is located at here. So I use the red color. So it's located at here from the second reference. Okay, it's located at here. Here. So this one, the final one is the final image is 3.72 centimeter to the right side of the second refracting surface. Okay, is it clear? Okay, that's it.